back to Fitness, Nutrition, and Soul channel. Today we're gonna talk about insulin and glucagon. I hope you enjoy this video. It is gonna be really scientifically, so be ready, guys. So let's start with the pancreas. So in the pancreas, the main four types of the cells. So first of all, the pancreas works as the endocrine and it also works as the exocrine. So the endocrine is the one which produces the hormones, and the exocrine is the one which produces the digestive enzymes, and it secretes the bicarbonate into the lumen. So there are four major types of the endocrine cells. So one is the alpha cells, which is the glucagon. One is the beta cells, which produce the insulin. Then you got the delta cells, which produce the somatostatin. And then you got the another one which produce the pancreatic polypeptides. However, in this video or presentation, we actually just gonna focus on the insulin and the glucagon, so which is the alpha cells and the beta cells. So let's have a look. So first of all, so every time when we eat the food, it can be protein, fat, carbs. So there's not just the one reason that if you like, it's only the carbohydrate which spikes insulin. It can be the amino acid. It can be distension of your stomach lining or the small intestinal lining. That can also with the help of the parasympathetic, that can also activate the beta cells to produce the insulin. So what does the insulin does? So it increase the glucose oxidation. So glucose oxidation means that the cell use the glucose as an energy source. It increase the glycogen synthesis. So glycogen synthesis means that when we eat the carbohydrates, the body stores the sugar or the glucose in the form of the glycogen in the liver and the skeletal tissue. It also promotes the fat synthesis. It also promotes the protein synthesis. So every time when we eat food, the insulin goes, or the blood sugar level goes up. So the beta cells then produce the insulin to drop the blood sugar level to the normal level, or to transport the glucose into the cells. So when the blood sugar level goes towards the lower side of the normal, towards like a hypoglycemia, then the glucagon is released from the pancreas by the alpha cells. So what glucagon does? Glucagon breaks down the glycogen stores in the liver into the bloodstream, so that your blood sugar level remains the same, so that you don't go to the hypoglycemia. So when the glucagon get activated, it causes the glycogenolysis. Lysis means breaking down, and nesis means when you build something. So glycogenolysis means that when your liver is breaking down the glycogen which is stored in the liver. Gluconeogenesis means making up. So when the body produces another form of the glucose from either from the protein, from certain amino acids, or the glycerol part of the fat, when that's called the gluconeogenesis. Neo means new, so it's when the body makes the new form or new glucose from different sources. And the ketogenesis activates when you're in the prolonged starvation, when your body starts using the fatty acid as an energy source. So how does the insulin activate it? So as I told you guys before, the insulin activates by multiple mechanism. So when you eat a meal, distension of the GI tract, stretch receptors, which is then sensed by the neuron input, and then the increase in the parasympathetic output, that can also cause the insulin secretion. The another one is the presence of the carbs. I didn't put the presence of the amino acids as well. So it can be presence of the carbs, the spark of the amino acids, and also like a GLP-1 and GIP, which is GLP-1 stands for the glucagon-like peptide 1, and GI is the gastric inhibitory peptides. That can also make the beta cells to secrete the insulin. So now let's see how does the Insulin helps to transport the glucose into the skeletal muscle, um, and into the first of all, we start with the skeletal and the adipose muscles, and then we'll go into the liver. So what we need to understand first is that the insulin is a protein hormone. So there are three major different types of hormones: lipid, protein, and the amine. So the insulin is the 51 amino acid protein hormone. So when it binds to the receptor, as you can clearly see over here, on the insulin receptor on the purple line, that is a cell membrane. So when the insulin comes and bind, in the second picture, when you see that the insulin came and bind to the cell receptor, so that's called the first messenger. So if it was a lipid hormone, it will diffuse into the cell, but the protein hormones cannot diffuse into the cell. They will has to come and bind to the receptors. So insulin comes and binds to its receptor, which then causes the second messenger inside, which is also called the signal transduction cascade. So you got the different types of the glucose transporter: glucose transporter 2, glucose transporter 4, glucose transporter 5. But in the adipose and the skeletal tissue, you only got the GLUT4. So when the insulin comes and binds to its receptor, the GLUT4 then it's called the exocytosis. That means that the GLUT4 then goes and binds to the cell membranes, and that's how the glucose then enters into the cell. But however, there's an amazing thing. So during the exercise, when the muscles contract, GLUT4 transporters are inserted into the membranes even in the absence of the insulin. So that means that when you're contracting the muscle, there is a reason behind it. There's a calcium involved and the other ions involved as well, that actually can increase the activity of the GLUT4 exocytosis to the cell membrane even in the absence of the insulin, and then it increases the glucose uptake. And that's why the exercise is really, really important for the people with diabetes. Now, in the next slide, we will learn how does the insulin works in the liver glycogen. So in the last slide, you saw that the GLUT4 was within the cell, which is called the cytoplasm. So the cytoplasm, but in the liver, there's different types of the glucose transporter. That is the glucose. It's called GLUT2. So that one doesn't. All the time it's present on the cell membrane. All it needs is the insulin comes and binds to its receptor, and then the glucose will start entering from the high to low. So if it is high in the blood and low in the liver, then the glucose will start diffusing or moving towards from the blood towards liver. So just have a look about just a little bit more information about the insulin. It's released by the beta cells. It is a 51 amino acid peptides. It dissolves in the plasma. Its half-life is only 5 minutes, and generally activates when the blood glucose levels goes above 100 milligram per deciliters. And if you want to convert into the millimole, then you just divide it by 18, which is used in Australia. And then it can be also activated by the glucagon-like peptides, or the spike in the blood amino acids, or the parasympathetic activities, or the inhibition of the sympathetic activity as well. Its target cell is liver, muscle, adipose tissue, brain, kidney, and the intestine. When you say intestine, not insulin dependent, because there's a different type of different types of the they are sodium glucose transporters. The whole it pretty much acts most of the tissues, and increase the metabolic use of the glucose as well. So it promotes the glycogen synthesis, aerobic metabolism of glucose. It also causes the protein and the triglyceride synthesis. And the action at the molecular level, as I explained before, it inserts the GLUT4 transporters in the muscle and adipose tissue and alters the enzyme activity and causes the signal transduction pathway, which I explained before, E2. And its main role is to transport the glucose into the cell and manage the blood sugar level. Now, as we discussed before, this is just a small slide what it activates and what it inhibits. So it activates the glycolysis, it activates the glycogenesis, it activates the lipogenesis, it activates the protein synthesis, and it inhibits the glycogenolysis, it inhibits the glyconeogenesis, it inhibits the lipolysis, and it inhibits the protein breakdown. Now, just a little bit of information about the glucagon. Glucagon is produced by the alpha cells, which I told you before. Its half-life is only 4 to 6 minutes, and it is generally enhanced when the plasma glucose is around only 65 to 70 milligram. And if you want to convert it into millimole, as I told you, can divide it by 80. And so for the people with the diabetes, how so these are the figures that which decide that if that's a fasting blood sugar level, if it is constantly coming above 6.9, that shows that you're diabetic. But the good thing is, if you're pre-diabetic, you're gonna have very great chance to reverse if you change your diet or your lifestyle and your eating pattern. So what are the foods which can help? So almonds have been associated with the lower levels of fasting insulin and the fasting glucose. Buckwheat is another one which can improve the glucose concentration. Consumption of 1.5 liters of oolong tea has also shown to improve the plasma glucose concentration. Chocolate and the coca is another one. Then you got the anthocyanin, which is found in the berries, especially the blueberries and the blackberries, is significantly improve the insulin sensitivity. Turmeric is another one, and also the cinnamon. That's it, guys. I hope you enjoyed my video, and if you haven't subscribed my channel, please do it now. Thanks for watching. Thanks.